All right, we are looking at our last section for Chapter 9 today. We're continuing to work with geometric series, looking at how we define them and how we find their sums. So what happens to a geometric sequence when our R value, our common ratio, is bigger than 1? So for example, let's picture when R equals 3. So 3 to the 0 power is 1, 3 to the first power is 3. Each time we multiply by 3, our next number gets larger and larger and larger. So if we were to graph those points, you can see that it's just an exponential growth curve. All right? So if I asked you to add those all up and it keeps going, you wouldn't be able to, because the next number up is going to be even larger, and it's going to keep making my total bigger and bigger and bigger. We call this a divergent series, and we will not be able to do this if the series continues to infinity. So yesterday we focused on the finite geometric sequences, where there was an end term or we had a set number of terms that we wanted to add up. If we are looking at a sequence that goes on forever, we cannot find the sum if our R value is greater than 1. But if we look at a situation where our R value is between 0 and 1, like a half, each time we cut something in half, the next number gets smaller and smaller. So for example, let's say we started with 1/2, our next number would be 1/4, then 1/8. Each time we cut it in half, the next little piece is half of the previous one. So if we were to take all of those halves, all right, so like this is half of the first one, okay, then this would be a quarter, half of a half, and then this would be half of that. Each time we keep cutting in half, if we put all those little pieces together, it really comes out to be a whole. All right, we can actually find the sum of it. So in short, we have two types of sequences. The ones where our R value is greater than 1, or if it's negative, it's smaller than -1. So things like R being -2 or R being 3. Those are what we call divergent. We will never be able to find their infinite sum. Okay, there's no sum for an infinite series. But if we have a convergent series, like the ones we just had here, we can find the sum of those, and we have a really easy formula to use to do that. So these, we can find the sum. Even if the sequence goes on to infinity, we can add all those little tiny pieces together to get an approximation for that total. All right, so our nice, easy formula for this, to find the sum of an infinite geometric series, we simply take the first term and divide by the quantity 1 minus r. All right, so again, put that 1 minus r in the denominator in parentheses. And we can only do this if the absolute value of our common ratio is less than 1. Or another way of saying that is our R value is bigger than -1 but smaller than +1. An infinite geometric series where the R value is greater than 1 or smaller than -1, we will not be able to find a sum. All right, so the first thing we're going to do is we're going to look at a few infinite geometric series and decide, do they converge or diverge? If they converge, we're going to find the sum. So looking at this, to figure out our R value, we take the second term and divide by the first term. Well, half divided by 1 is just 1/2. And you'll notice that each time we're taking half of the previous number. So 1/2 is a value that fits in that range. So this one we would say converges, and so we can find the sum. All right, our formula says we need the first term and we need our R value, and we know both of those. So our total here, and notice that there's no little number down here because it's going to infinity. All right, we're finding an infinite sum. That's what the little ... here implies. Okay, so the sum of all these numbers being added up, we take our first term, which is 1, we divide by 1 minus our R value. All right? And you can use a calculator, but we can actually figure this one out pretty easily. 1 minus a half is just a half, and 1 divided by a half is 2. Dividing by half is the same as multiplying by its reciprocal. We end up with 2. This next one is in that summation notation, right, with that Greek letter sigma. But notice up here, the upper limit is infinity. That tells me it's going to keep going forever and ever. Okay? Our R value is the piece that's being raised to the power. So in this case, our R value is negative 5/4. And since that is a number outside of that negative 1 to positive 1 range, all right, this is negative 1.25, so that is too big for us to figure out the sum. We would say this one diverges. So there is no sum. Each successive term is going to be bigger and bigger and bigger, which means we cannot find a total for them. All right, next one. Let's look at finding our R value. Remember, we take our second term and we divide by the first term. So 3/4 divided by a half is the same as 3/4 times the reciprocal. So we end up with 6/4, but that's 1.5. And since that is bigger than 1, we say this diverges, and there's no sum. All right. For this next one, let's calculate our R value. Notice that our second term is negative 1/9. We're dividing by the first term, 1/3, which means we're taking negative 1/9 and multiplying by 3/1. We get negative 3/9 or negative 1/3. And that does fit in our range from negative 1 to positive 1. So this we say converges, and we can find the sum. All right, our first term is 1/3. We're dividing by 1 minus a negative 1/3. All right. So again, we can do this by hand. We have 1 minus negative 1/3 in the denominator. That would be 3/3 plus another third. This is 4/3. So our sum is 1/3 divided by 4/3, or just 1/3 times the reciprocal. So our sum ends up being 1/4. All right. Our last one on this page, we have, again, a series that is going to infinity. Our R value is the piece being raised to the power. So our R value is 2/3, and that does fit in our negative 1 to positive 1 range. So we say this converges, and we can find the sum. But we do have to figure out our first term when it's in this summation format. To find the first term, we start with our first number here and plug it in. So we put a 1 in there, so we have 2/3 to the first power, or just 2/3. So our first term and our R value are both 2/3. So the sum is the first term divided by 1 minus the R value. And 1 minus 2/3 is 1/3. So 2/3 divided by 1/3 is the same as 2/3 times 3, which is just a 2. Now again, we could use our calculator to do that. All right, so we had 2/3. We'll put that in parentheses. All right, that's our top piece. 2/3, we're dividing by, parenthesis, 1 minus 2/3. And we should get a 2 for an answer, and we do. All right, so let's take a minute and review a few things that we've covered for geometric sequences. Let's start out with our recursive rule. Our recursive rule, we always have the first term, so we state a sub 1 equals something, and then our nth term is our previous term times r. Our explicit formula says the nth term is the first term times r to the n minus 1 power. We also found a geometric mean by multiplying the two terms together and square rooting that. So this is where we have, first term missing a middle term and then a third term. We can find that missing term by multiplying them and square rooting it. All right, and then we had some summation formulas. So our summation formula for just a finite geometric sequence, we had first term times 1 minus r to the nth power over 1 minus r. And then if it's infinite, we had the one that we looked at today, first term divided by 1 minus r. All right, so those are all the formulas that we've looked at for geometric sequences. Our example here says to write the explicit and recursive formulas for the geometric sequence 7, 35, 175, 875, and then find the seventh term. All right, so we know our first term is 7. Our r value is just the second term divided by the first term, so we're multiplying by 5 each time. So my recursive rule would state that the first term is 7, and each term after that takes the previous term and multiplies by 5. Our explicit rule says the nth term is the first term, which is 7, times the r value to the n minus 1 power. And then to find the seventh term, we're going to use the explicit formula and put a 7 in for our power. So 7 times 5 to the 7 minus 1, or 6th power. 7 times 5 to the 6th power. Let's grab our calculators. 7 times 5 to the 6th power. We get 109,375. All right. Next question. It says use the geometric mean to find the missing term of this sequence. So again, to find our missing number here, and it could be positive or negative because we don't know if this sequence is alternating signs or not since we don't know the next number. We can find that missing one by just taking the positive and negative geometric mean. We take 70, multiply it to 17.5, and then square root it. So we need the square root of 70 times 17.5. All right, so square root 70 times 17.5, and we get 35. So our missing term could be positive or negative 35. All right, our last question says to write an explicit geometric rule and find a sub 8. So what do we know? We know our first term is 3, and we know our fourth term is 192. But we don't have consecutive numbers, so we can't simply divide out to figure out our r value. So let's start with our explicit formula. A sub n equals first term times r to the n minus 1, and fill in what we do know. Our first term is 3. We do not know r, but we do know that when we use an n value of 4, we get an answer of 192. So we can plug in a 4 for n, and we should get 192 for our answer. We can divide by 3. So we have r to the 4 minus 1, or third power, equals 64. And then we can cube root. So our r value would be the cube root of 64, which is just 4. All right. So now we can write our explicit rule. A sub n equals the first term times r to the n minus 1. Then we want to find the 8th term. So we'd have 3 times 4 to the 8 minus 1, or 7th power. So 3 times 4 to the 7th power. And we get 49,152. All right. Now, they didn't ask us, but let's go ahead and do one summation formula from yesterday. Okay, let's find the sum of the first 8 terms. All right, so we're making this a finite series. All right, we're stopping after 8 terms. So we want to find the sum of those 8 terms. We need our first term, which is 3, times 1 minus our r value. R was 4. To the nth power. We're adding 8 terms together, so our n value is 8. And we divide by 1 minus our r value, 1 minus 4. All right, so we have 3 times 1 minus 4 to the 8th divided by 1 minus 4. All right, so 3 times 1 minus 4 to the 8th. We are dividing now by 1 minus 4. And we get a total of 65,535. All right. So we are finished with our new material for Chapter 9. Today you'll be working on worksheet 9.5b.